In this video, we're going to upgrade the language level from beginning student with list abbreviations to intermediate student with lambda, all right? So if you go to the bottom left corner and click intermediate student with lambda, and you see this on the bottom left corner, this is going to be wrong. And repeat, this is going to be wrong if you see intermediate student with lambda on the bottom left corner. What you need to be doing is clicking this bottom left corner again, go to choose language, and then click this first one over here, the racket language, and then hit OK. It should give you this error, right? No program to process. So to fix this, make sure you have for the first line, #lang http/ISL plus, right? That's going to be in line 1 of every program from now on, right? So just to repeat, we're moving away from these menu-based languages over here, right? We're not doing these. We're doing this and then this #lang. Why? Because these are old, and this #lang provides much better features and defaults, right? So you should see this definitions over here, text over here when I hover over the definitions, and then interactions over here when I do this, right? If you see this, then you're good to go. If you don't, then you should probably, change the language level, put this over here like so. All right, so one of the cool things about these #lang languages is that there are a lot of good defaults. So one of which being, if I hover over anything, it's going to show all the uses of them. And if I hover over anything else, right, it's going to show where things come from, right? So if I hover over this demote keyword, right, this demote function, here are all the uses, and here's where the demote function comes from, right? And if I hover over this demote over here in the function definition, it's going to point to all the uses. If I hover over this R here, right, it's going to show where this R is used. And if I hover over them inside the function, it's going to point to where this R refers to, like so. And it does so automatically without needing to press this check syntax button, right? Because that's what you had to do before, and it was slow and clunky. And yeah, that's why we're switching to #lang http/ISL with this determined language from source here. All right. So in this video, we're going to write checked signatures. So far, signatures have just been type comments, and comments are ignored by the program, and this leads people to be very sloppy with signatures, right? They're going to write them very messily, maybe skip them, and etc. Well, no more of that, because we're going to write signatures that will be checked by Racket. So if you go to this URL, which will be linked in the description below, it's going to show you how to write checked signatures, right? So here's one good example. So this is how you write the signature for this function cute. So how it reads is cute is the name of the function, consumes an enum, which is either a cat or a snake, and then produces a boolean, as you see in this function definition. All right. So this is how we're going to be writing signatures from now on, and it's going to give us a lot of benefits, as you'll see shortly. All right, so let's start off by transforming this demote type signature, that's just a comment, to a checked signature, all right? So this is the syntax for it, right? So we're going to hit enter, and we're going to write open parentheses, colon, space, and then the name of the function. In this case, it's demote, right? So then we're going to need space, another set of parentheses, and this indicates that this is a function, right? So this could be string to string, right? Because these enumerations are just strings, and this does work, right? But we want to be more specific. These aren't any strings. These are these set of specific strings: bronze, silver, gold, platinum, diamond. So this should be enum. So what you need to do to make an enum signature here is you need another set of parentheses, a call to enum, and then list all the strings, right? The set of strings that an enum can be, right? The rank enum can be. So bronze, silver, gold, platinum, and then diamond, right? So this, right, the original type signature is a rank and produces a rank. And this is what a rank is. It's all these sets of strings. So let's also do this here, right? Like so. So this arrow and then greater than sign means produce, right? So produces this set of enums, all right? This enum of a rank. So it works, right? And if I hit run, right, it's all good. So one of the benefits of this is that if I type something like call demote with, let's say the string, let's say I made a typo and I didn't capitalize bronze, right? This B in bronze, right? It's specifically a capital B. Let's say I mess it up, or I, accidentally add another Z at the end for some reason, right? I'm making typos. And I hit enter, it's going to point to the signature where it violated the function over here, right? So it may point to this con, but if you click here, right, it's going to point to this enum, and it says this is where the problem started, right? Like so. If this function, right, this check signature was not here, and I hit run again, and then I call food with bronze, right, it's going to point to this con, right? And it says the con is wrong. The con isn't the problem. The problem is that we passed demote with this, bronze, this misspelled enum, right? Because a rank is one of these strings. It can't be this, right? Like so. So that's one of the big benefits of check signatures, like so. Right? So one of the problems is this duplication over here, right? This and this are the same, right? You kind of want this more compact version. So what you need to do is define a variable called rank. So notice how all types are capitalized, right? So the first letter of all types are capitalized, and we're going to keep that convention going forward. So we're going to define ranked as a signature variable, like so, and it's going to be this enum, like so. All right, now in place of this, we can just type in rank, and if you hover over it, it should point to where it is, right, where it's coming from. So this is back to the first version, similar to the type comment over here, but more compact, right? But you're going to need this define line, right? Define signature line, like so. So if I run this code, right, and I write demote, and let's say, I got tired and spelled cold as, fold, right? Fold. It's going to point to this con, but if you click this link over here, it's going to say signature violation, right? Signature violation, that's going to give you a pretty specific hint that you got the signature wrong. You passed some bad data to demote called fold. Fold is not one of these strings, right? It's not this enum right over here. It's something that this function is not accepting as valid input. So you get better error messages like so. So let's keep going. Let's do the next type signature that we need to convert, right? This is the function that we've done before. It's called can walk, right? Like so. And it's an union, right? It's a union / itemization / mixed data, right? So a walk late can be one of either a number from 0 to 10 or the walk and stop, right? The strings walk and stop. So this is the type comment itself. Let's convert this to a check signature. So parentheses, can walk is the name, another set of parentheses, right? To indicate that this is going to be a function, and then a walk late. So let's just type this out manually. So a walk late is going to be mixed, right? And then you're going to type in number, right? Number, and then these other strings have to be wrapped in enum. So you have to do another set of parentheses, enum, and then walk, and then stop, right? So this is just this mix block, right? This mix block is what it consumes, right? This walk light, right? This is what it is, right? It's this type comment. So these are all the same thing, right? This produces a Boolean, right? Again, right? They're all the types start off with a capital letter, like so. So I run this code, it works good. And let's say I pass, can walk a Boolean, like false, right? It's not a Boolean, it can't consume Booleans, it can only consume numbers or enum, walk, or stop, right? These two strings. So that's gonna point to this branch, but beyond that, if I click this signature, right, violation over here, this error message, it's gonna say that it comes from here, right? So I can, again, if you don't like this and you want a more compact notation, you just cut it, type in walk light, and then define the signature variable like so. So define walk light, and then signature, and then that, like so. All right, so that is how you type the signature for unions, right? Mixed data. You have to write mixed, and then a number, and then an enum if you want to, write the different types of here, because unions, right, they're different types, right? Notice how this is a number and these are strings, right? It's mixed data because of that reason. All right, so now let's move on to structures, right? Structures right over here, right? So we have a define struct, employee, it's a name, age, and wage, right? You can guess this is probably a string This is a number, and this is also a number, right? And here is increased wage, right? It consumes an employee called PS, and then a number, N, and it spits out an employee, all right? So what we need to do is turn this into a check signature. So open parentheses, colon, the name of the function, increase dash wage. It consumes an employee, right? So employee, and then a number, and then produces an employee, right? This is how you would check properly type that, like so. But this is not good, right? It's not all there, right? So if I do something like, increase wage, and then make employee, and let's say for the first signature, right, this name over here, and let's say I'm just tired and I, passed in Boolean instead of a string, right? It should be like a string Bob or something, but let's just say that name is false. Right? That's not really valid, right? And the age, let's say, is 20, wages 10, and then the N for this function is like $5, right? We're trying to increase this wage like so. So if I hit enter, right, it's still going to work. But this is wrong, right? We want to get errors that say, hey, right, the name should be a string. Your name can't be false. So you need a struct signature, right? So to do a struct signature, right, what you have to do is, if you check the documentation here for structs, it goes into much more detail as to what a defined struct does, and it's going to provide all these things. But what we really care about is defining a struct signature. So what we need here is we're going to abstract to a variable shortly, but employee, right, it's not just an employee with these types being anything, right? This should be a string, this should be a number, and this should be a number. What we need is to do something like this, where you do employee of, and then string, right? Because the name is a string, age is also a number, and wage is a number, right? So this is what it consumes, right? It consumes an employee with these variables as the fields, a number as the second argument, and then it produces an employee like so. So I run this, and then I press this, right? I'm going to get a signature violation. Hey, false can't be your name. This has to be a string like so. All right. So let's factor this back out into a signature variable, because you probably don't want to, care about this employee of string number in this signature for increased wage. You want it looking more compact like this type comment signature, right? So let's factor it out. So we're going to write define employee sig. Right, you might be tempted to just write employee, but that's taken when you write, define struct employee, right? This capital E employee is already taken, so you have to name it something else. So we'll call it employee sig, and then we're going to call signature to make this a signature variable, and we're going to pass in the signature right over here, right, like so. All right, so everywhere we see this, we can replace it with employee sig. So here and here, and it's looking a lot more like the comment version, right? Much more compact. So increased wages consumes an employee and a number and produces an employee, right? So if I hit run, and if I run the same code as I did before, where false is not a string, right? Like Bob, it's a Boolean, right? We're getting an error saying, hey, right, someone messed up, someone passed a Boolean to something that should be a string. All right. Now let's move on to typing list, right? List signatures. This is a double all. This double all function consumes a list of numbers and produces a list of numbers. And if you see this double all, doubling all these numbers in this list, 1, 2, 3, produces the list 2, 4, 6. All right, so let's make this a properly checked signature that Racket will check for us. So colon, double all, right, it consumes, so this is this opening parentheses, right, it's going to be the function call over here, and we're going to need another set of parentheses for list of, right, where you need to call list of, and then say this is a number, right, so this turns into this, right, parentheses, list of number, and then arrow, and then parentheses, list of number, like so. So this is how you would do the check signature version. Space list of number, my bad. Like so. If I hit run, right, everything still works. If I call double all with, let's say, list 1, 2, and let's say someone got tired and put the string 3 rather than the number 3, right? They wrapped it in quotes over here. Hit enter, right? Up. If I spell double right, double with an L, right? I get a signature violation, hey, right? It should be a list of numbers, not list of a string and then a number at the end, right? Like so. So I get this correct error if I click this like so. Without it, right? Let's say I'm going to comment out this signature, and it's going to be a comment, so it's no longer going to be a checked signature. And I call double all with list 1, 2, 3 with a string 3, right? It's going to say, hey, right? This is where the error is, right? It's in this function, and you're going to be like, hey, times expects a number given this string 3. You might be tired and just look at this and go, I don't know what's wrong. It looks like I'm passing 3. What the heck's wrong, right? So yeah, this is why we should revert back to check signatures, and it will give you a much better error messages, right? Like so. It's a signature violation, right? And you're going to see this error right here. All right. So now let's move on to the next problem. So list of structures. So list of structs, we have a function called raise all wages. It consumes a list of employees, a number, and then produces a list of employees. It produces the given list of employees with a wage increased by n. So this is that number n. This is wage 15. We're just going to add 2 to 15 to raise Bob's wage, right? All right, so let's properly make this a checked signature. So open parentheses, colon, space, the name of the function, raise all wages, consumes a list of employees. So this first set of parentheses is for the function itself to indicate that this is going to consume. This is going to be a function that consumes and produces things. We need a second set of parentheses for this list here. And to type this out, that's going to be list of, and then the type, right? So employee sig, right? Employee signature, right? And then that's this first argument to this function. Second argument is a number. So it can just be number like so. And it has to be a capital N. It can't be a lowercase n. Just a quick reminder. All right. And then, so that's these two arguments. And then we need an arrow. And then it's going to produce a list of employees yet again. So list of employee sig. Hit run. We are all good. So if I pass in, raise all wages, and then the list over here, right? And then we'll say 2, right? Let's say I made Bob false, right? Since this function, right, calls the increase all wages, and this, it's going to check the employee sig, we're going to get a signature violation saying, hey, someone passed something that's not a string into this field, right? So you might be tempted to just write, this, just be like list of employee. But if you do that, right, like so, you're not going to get this specific error messages. So if I hit run, and then I click this, right, let's say here, for some reason I still get that, but, it shouldn't say that. Oh, no, I'm getting it because this function, raise all wages, calls increase wages, right? And then I'm getting this violation from this function, right? So you shouldn't use you should use the more specific version that you defined with the type over here, right? This employee sig, right? We're using employee sig because we're saying it's not an employee where the name can be a Boolean, right? We're saying the name has to be a string, the age has to be a number, and the wage has to be a number, right? Because you can pass any type to this name, right? It could be a Boolean, whatever. No, we're saying no, it has to be a string, right? So this is what you do. This is what happens if you only put employee here. The reference and employee signature, right? Like so, the employee sig that we defined above. And that gives us a better error message, right? Because if we click this, right, it points all the way up here, but we want better errors, multiple errors, right? This one has multiple errors, and it's saying, right, it gives us 2 errors, and it tells us where they were violated, like so. But anywho, that is how you type signatures, and that's what we'll be doing for all the upcoming problems. So you can always ignore them, right? If you're having problems typing these signatures up, right? Just make them commas again, and then come back to them and do them a little later. Nonetheless, right, here's the web page for it, right? Here's how you type all these signatures, like so. And here are all the types. So they're all the way down here. And here are all the types for these signatures. Any, right, for anything. and then Boolean, char, cons of, false. Right? Notice how the types always start with a capital letter, right, for these signatures. And you're going to see that as a recurring theme. All right. And that is about it for this video. So notice how if you do these type checked signatures, you can get better error messages. And when we get into big programs that we have functions, calling functions, you're going to be very appreciative of really typing these checked signatures early on, because they're going to point you to better errors from the get-go. Right? So that's about it for this video, and I'll catch you in the next one.